Welcome everyone for the video lecture series on Mechatronics Systems. In this video, we are going to continue from where we left off from the earlier video. So we will be looking into the pneumatic systems. This will be the second part of the pneumatic systems. Pneumatic systems is part of the unit 3 for the course Mechatronics Systems. I'm your course instructor, Mr. Prashanth N. So let us continue with the part 2 of pneumatic systems. So just to recap a little bit, so in part 1, we basically looked into the fluid power systems, the different classification of fluid power systems, and then we looked into various gas laws, and then we introduced to the pneumatic systems, so the various subsystems of pneumatic systems. Then we discussed the advantages, disadvantages, or the limitations of pneumatic systems. Then we also looked into the basic components of pneumatic systems such as compressor, service unit, and then control valves, power valves, and actuators, that is cylinders, etc. So we discussed each of these subsystems in detail. We looked into their physical appearance as well as the symbols. We also discussed the air service unit in this, and we also discussed the valves in general. So we have discussed the functions of the valves, and later on we also discussed the nomenclature of the valve and the functioning of different types of direction control valves. So that is 2x2 direction control valves, 3x2 direction control valves, and 5x2 direction control valves. So we discussed these in detail. So this was part of part 1, and also finally we ended up with various symbols of direction control valves and functions, and also we looked into the valve actuation methods for the direction control valves. So this was the part of the part 1 of the video lecture series on the pneumatic systems. So now we will continue with part 2 of the pneumatic systems. So to begin with, we'll take up different types of control valves. In this, first we look into the non-return valve. Non-return valve is also known as a check valve. So a non-return valve basically allows the flow of air in only one direction, right? If it is if the flow of air is another direction, then it will stop the flow of air, but it will allow the flow of air in the only one direction. So this is how it looks like physically, and this is basically the cross-section figure of this. And the symbol of the non-return valve is as follows: there is a ball, there is a spring. So basically how this works is, it's very simple. Suppose if I pass the air in this direction, so you can just see, if I pass the air in this direction, right, so the air will enter and it will push this ball or this element, and this element will be pushed against the spring force, and as a result the air will get the passage, so it will basically move and it will escape, right? It will move to the other end. So that is how the air will be able to move from this side. So suppose if I supply the air in the opposite direction, right? So if I supply the air in the opposite direction, so then what happens is air enters here, and as it enters, it will push against this particular wall. This ball is pushed, and this ball in turn will push against the wall of the valve, and as a result, the air will not be able to move to the other side, right? So if you see this, this is exactly how it is represented in the symbol. So if the air is coming from this side, so the air will push against the ball will sit on the valve seat here on the walls, so the no air will come at the output, right? So if there is air which is coming from this side, so this will push the ball against the spring force, and as a result air will be passed at the output. So non-return valves or check valves are very widely used when you want to control the flow of air in only one direction. So this is something you can say analogous to, let us say, a diode in an electrical system. In an electrical system, as you know, there will be a flow of current in only one direction, but the current from the other direction will be stopped. The same function is performed by a non-written wall or a check wall in pneumatic system. So next, we will look into flow control valves. So the flow control valves are basically valves which will control the amount of the quantity of air being supplied to the pneumatic system. So here it is also known as a throttle valve. So here what we'll be doing is we will be controlling the amount of air or amount of fluid that needs to be supplied to the pneumatic system or pneumatic circuit by throttling the cross-sectional area of the valve. So the physical appearance, it appears something like this. You can see there is a knob here, and where there is a knob, obviously you can vary it. So the symbol of this throttle valve is as follows. Now if you see this symbol, this is basically a combination of two different valves. So this is basically a throttle valve. You can see this arrow mark. Arrow mark indicates it is a variable, so that means you can open or close this with various degrees. And then it also has a check valve or a non-written valve attached to it, right? So it is basically a combination of both a non-written valve as well as a throttle valve. So if you want to know how this works in detail, so let us look into this figure. So in this, if we observe the working principle, let us say I want unrestricted flow of air. So that means free flow of air. So in that case, if I supply the air in from this direction, the air will enter the chamber. So instead of air going to this direction, right, so air will move to this direction along this side, and it will push against this ball. And then once the ball is pushed, or this wall is pushed against the spring force, it will get the passage and the air will basically escape, and it will be transported to the other side of the port, right? So that is how basically air moves free flow. That means it is not throttled, the air is not throttled at the output. Now the reason why air would prefer to take this path rather than taking this path is air always takes the path of least resistance. When air is inserted, inputted into this particular port, the air pressure pushes this ball, and as a result there is a least resistance in this direction, and as a result the air will escape. Now if I want to have a restricted flow, or in other words a throttled flow, so in that case, if I supply the air from this side, the air will enter. So it will enter this side also, but here the air will push against this wall, so there is no way the air can move towards the other end. So the only possible means of air to escape or to get transported to the other port is through this small cross-section area what is present here. So as you can see, I can increase or decrease this by just rotating this. If I rotate this particular knob, it will increase or decrease the cross-section area through which the air can flow, right? So this movement or this throttling is what providing the restricted flow. So by just adjusting the required amount of cross-section area, I can easily control the amount of air to be passed from input to the output. So these are the two functions. So this is the reason why you also have the check valve along with the throttle valve. Now if you just would like to have a throttling in from both the sides or both the directions, then you can eliminate or you can remove this. So if we remove this, obviously when you pass the air from either directions, the air will be throttled. So that is flow control valve. So next we will look into another type of valve which is known as a shuttle valve. Shuttle valve is also known as OR valve. So we are all familiar with OR function, and OR is a logical function. So what is OR function? The OR function basically is, if you have two inputs and one output, if any one input is present, then you will get the output, or if both the inputs are present, then also you will get the output, right? So that is basically the OR function. So in this case, the shuttle valve, the physical appearance of the shuttle valve looks something like this. You can see here. So in this case, you will get, you have three ports, two input ports. You can see these are the two input ports, and then there is one output port. This is the output port. So what happens is, if you look into this cross section, so if I apply the pressure P2, right? If I apply the pressure P2, then obviously the ball will be pushed against the other side of the port, and the air will easily pass towards the actuating port or the output. If the air is removed from P2 and is applied at P1, right? So this will push this ball. So this ball will come and sit here, and as a result, the air will basically pass from this P1 port to the output port A, right? So when both are applied, then obviously it basically takes the pressure which is high pressure, whichever is having a higher pressure, so that will be taking the precedence over the other port. So that is how it basically works. So if there is a low pressure coming from P1 and a high pressure from P2, and obviously the P2 will be channeled to the port A, or vice versa, right? So the symbol for this is as follows. You can see the symbol of the shuttle valve. This is the symbol which is used for the shuttle valve. So these type of valves, shuttle valves, are used wherever logical operations needs to be performed. And as we know, logical operations, one is OR, there is another logical operation which is AND logic. So that is known as dual pressure valve in pneumatic systems. So AND logic can be achieved using dual pressure valve. So in this, the dual pressure valve follows the AND logic, in which when the output of the valve is obtained only when both the inputs receive the signal, right? So that is the AND logic. So AND logic basically tells if there is signal at the input, both the inputs, then only you will get the output. So this is the physical appearance of a dual pressure valve. So you can see there are two different inputs, and then there is this one output. Now if you see the cross section, or if you see the functioning of the dual pressure valve, so this is how it works. Now you see these are the two inputs. So here you have one input, here you have another input. When I apply air pressure to both the input, so the spool will be positioned in such a way, somewhere in the middle it will be positioned, and as a result you can see the air will pass through from both the ports, and it will merge and it will be passed to the output. So the output is obtained when both inputs are present. Now suppose in the case where I apply only one input, right, in this, and here I will not apply any pressure, air pressure. So in that case what happens is, obviously the air pressure will push against this particular the spool, and as a result this air will have no passage to move towards the output, so there will not be any output. So this is clearly explained using this symbol, right? So the symbol for the dual pressure valve or the AND valve is as follows. So this is the symbol, ISO symbol, which will be used in the pneumatic circuits. Now where will you come across the application of these type of valves? For example, AND logics are very widely used whenever the control signals whenever there is safety of a pneumatic circuit is required, let us say in the operation of a pneumatic press. So in the operation of pneumatic press, so just to ensure the safety of operations, the dual pressure valves or the AND valve is used, such that if I press two buttons simultaneously, then only the machine should operate. So this can be used as a safety mechanism, so that you can prevent any accidents while operating machines such as a pneumatic press, or for that matter even the hydraulic press. So that is dual pressure valve. Next we will look into the actuators. Now the actuators, here we will be only discussing linear actuators. Pneumatic systems also make use of rotary actuators, but they are not widely used as compared to that of linear actuators. The linear actuators are basically, there are two types. One is single acting cylinder, the other one is a double acting cylinder. So first let us look into the single acting cylinder. So this is the cross-sectional view of the single acting cylinder. So if you observe this, the single acting cylinder, this is how it will look like in physical form, and this is the symbol of the single acting cylinder. The reason why it is called as a single acting cylinder is the actuation of the cylinder, the signal required for the actuation of cylinder is happening in only one side, whereas the return signal or the return force is basically provided by the spring which is present inside the cylinder itself, right? So you can see the single acting cylinder has only one port. So when you apply the force, or when you apply the air into this port, the piston will push, or it will extend against the spring force, and when you release the air from this side, piston side, then due to the spring will restore the force, and as a result the piston will retract backwards. So this is basically a single acting cylinder which is widely used in industries. Now similar to this, you have double acting cylinders. The only difference is in double acting cylinders there will not be any spring. You can see there is no spring, but you can see there are two ports. So here the forward stroke and return stroke both requires the user input from the control valves or the power valves. So the symbol for the double acting cylinder is something like this. You can see there is one port here, the other port here. So the double acting cylinder, the reason why it is called double acting is very simple, because the forward stroke and return stroke both requires the signal, the control signal from the various different types of valves that is used, right? So these two cylinders, single acting cylinders and double acting cylinders, are very widely used based on the requirement of the pneumatic applications. So what we'll do is, we will just spend a little bit more time and analyze how to actuate, or how this pneumatic system basically work on a whole, when all the components are interconnected, how this basically operates. That is what we'll look into in a moment. So before that, small recap. So as you know, the valves of the pneumatic systems, the control valves of the pneumatic systems, which we have already discussed, that is 3x2 direction control valves. There are normally closed type, normally open type. All these different types of valves can be actuated either mechanically, so you can make use of lever pulleys, or you can make use of the vertical piston levers, or it can be actuated manually as well. So you can see these are the different means of mechanical or manual operations. So this is mechanical operations, these are manual operations. So I think this you have already looked into in part 1 of this lecture series, so I'm not going to spend more time on this. What we'll do is we'll move to the principle of pneumatic control. So let us look into this simple circuit and analyze how basically a double acting cylinder is controlled. So if you see this, In this figure, this is a pneumatic circuit. In the pneumatic circuits, it's basically a simple pneumatic circuit. Here we have not shown the compressor, or for that matter the air service unit. We have used a symbol. This symbol, if you see this circle with a dot, and this symbol indicates the source or the compressor. So this is where the air is present. That is a short symbol. That is what is representing here. We have not described the circuit in its entire form. So this is a short illustration of the pneumatic circuit. So what are the different components that are there? So here you can see there is a 3 by 2 not 3 by 2, sorry, 5 by 2. So you can see there is basically 5 ports. So here 3 ports, 2 exhaust ports, 1 input port, and then 2 output ports. So this is a 5 by 2, 2 positions, 5 ports, 5 by 2 manual push button type direction control valve, which has a spring for the spring return. So here the output is given to a double acting cylinder. You can see there are 2 different ports, so it is a double acting cylinder. Now let us look into this, how it functions. When I sorry, yeah. So in the default positions, so if you see, the air is given directly to the rod end of the cylinder. So when the high pressure air reaches the rod end of the cylinder, the air fills up this particular portion. So when air fills up that particular portions, so what happens to this piston? The piston is supposed to move backwards. So this is known as return stroke, right? So it will basically, when air is applied, it moves to the return stroke. But the air which was present on the other end obviously will be exposed to the atmosphere, and it will be exhausted, right? So this is the return stroke. Now if I have to enable this to the forward stroke, so that I want the forward stroke of the cylinder, of the piston, sorry. So in that case, I have to actuate this button. This is manual button, so that I can shift the position of this valve to the second position, right? So second position, if you see, the input has to go to this side, that is the piston end, and the exhaust, whatever air that is already present in the rod end of the cylinder, should get exhausted, right? That is my requirement. So let us see what happens when I push this valve to the second position using a manual switch. So let us assume I'm pushing this manual switch. So when I push the manual switch, see, you can see the valve has shifted. Now what will happen is, the air, which is high pressure air, which was present in the rod end of the cylinder, obviously is exposed to the atmosphere. So and as a result, it will get exhausted, and when the air is applied to the piston end, the piston basically moves forward. So this is my forward stroke. So I'm going to show it once more. So the supply of air is given, so air will enter through this channel. You can see the air is entering, and it is pushing the piston, and the whatever air which was present on the other end is getting exhausted, right? So like this, you can control the forward stroke as well as the return stroke in the pneumatic systems. So these type of cylinders were very widely used in various applications. So we will look into a couple of applications where such type of cylinders are used. So first, let us take a simple example of direct control and speed control of the single acting cylinder. So here you have an example where single acting cylinder is there. It is direct control because the output of the control valve is directly given to the actuator. Of course, in between this actuator and the direction control valve, you have the flow control valve here. So this is basically one-way flow control valve. So this we just now discussed. So what happens in this case is, by default, you can see the air is supplied towards this position. So this is the input, So this air is blocked right now, so there is no way the air can move to the cylinder, so it is blocked. So what we have to do, we have to actuate the wall, so we have to press the wall. So what I'll do, I'll just press the wall, and when I press this wall, the wall has shifted. You can see the wall has shifted. So now the air can basically move from the input, that is from the compressor. It will move, so air will also move towards this side, but that side is basically you have a check wall, so the air will push against the ball. So the poppet wall, basically this ball will be pressing against the wall of the valve. So as a result, the air will not be able to pass through that. So the only possible means in which the air can move is through this throttle valve. So the throttle valve, as you can see, there is this arrow mark. This arrow mark indicates it is variable, so I can control the amount of air that is getting filled in the piston end of the cylinder. So when air fills up this particular portion, so obviously there will be a forward stroke of the single acting cylinder. So if I have to retract back, so obviously the moment I release this, so you can see here the spring is pressed or compressed because I am just holding it, and if I release the input switch, it will the spring will retract. So this will push the wall, or it will restore the wall to its original position, and as a result, whatever air that is present in this side will basically, it will pass through the same, or pass through this direction, pass through this it will come out of the cylinder, but instead of going through the throttle wall, it will move towards the check wall. Now the ball gets pushed, so as a result the air can easily pass through that, and it will pass through these walls, and finally it will get exhausted at the output. And the reason why this is the piston is retracting back is as a result of the spring. So when it extended, the spring was compressed, and when the wall got shifted, whatever air which was present here got exhausted, and as a result the spring returned the force, and as a result it basically the piston came back to its initial position. So here I can control the speed. So here we are also controlling the speed. So how to control the speed? The speed can be controlled by controlling the cross-section area, right? So if I can control the area of the throttle wall, so this in turn will control amount of air that is being fed to the cylinder, and as a result I can easily control the forward stroke of the single acting cylinder. So this is how a single acting cylinder, which is directly actuated, and here we're also controlling the speed of the cylinder. So let us see the same example but little bit modification. So instead of single acting cylinder, I'll be using a double acting cylinder. So you can see in this case I have a double acting cylinders. So since it is a double acting cylinders, obviously I have to use a 5x2 wall, and in between the cylinder as well as the control wall, I have two throttle valves and non-written throttle valves. So in this case, basically such type of cylinders or such type of circuits are used again to control the forward stroke, the speed of the forward stroke, as well as the return stroke. So similar to the previous example what we discussed here, the pistons, the circuits wherever you require the actuation, the speed of actuation needs to be controlled. In those scenarios, you can make use of the non-written valves with check valves. So this type of throttling, there are two types of throttling here. So one type of throttling is called as inlet throttling. So you can see inlet throttling. This is basically this is not an inlet throttling. The reason is when the air comes to this direction, so it will easily bypass the throttle valve and it will enter. So air is not throttled while it is going inside the the cylinders. Whereas if you look into the other end, so if you look into this side, so when air is passing through this, in this side also, this time also there is no way it is basically going through throttle wall. Here also again inlet is being not throttled, so it is non-throttled inlet. The outlet, so when the piston tries to move forward, whatever air that is present in the rod end of the piston of the cylinder, when that comes, so here that cannot pass through the check valve, it has to pass through the throttle valve. So this is basically from both the sides, it is known as outlet throttling of the air. So that means whatever the air which is getting exhausted or which is coming out from the cylinder, double acting cylinder, is being throttled. So in both the cases, this is outlet throttling. So if you see this, where you exactly will basically make use of, obviously, as I told, to control the speed, right? So if you want to move the piston slowly, obviously you can make use of this. If I increase the area, cross-section area of this throttle, then the reciprocation, the speed of actuation can be increased, right? So in this case, obviously both forward stroke and return stroke both can be, the speed of both can be controlled with the help of these valves, that is outlet throttling valves. So I hope this gives you a brief idea about how a pneumatic circuit works. So if we come to the applications where exactly these type of circuits are used. So suppose here you have a simple application where let us say some components need to be fed to the conveyor, and these components are loaded or stacked one above the other, and then you have a pneumatic cylinder. It may be a single acting cylinder. So the single acting cylinder will just push these components, and they will allocate, or they will transfer these components to the to the conveyors wherever it is required. So when the pneumatic the piston actuates, and it will basically push these blocks onto the left hand side, so the remaining blocks will come down due to the gravity. So it is a gravity feed, so it will come down due to the gravity, and as a result, in the next stroke, when again the piston pushes, again two more components can be loaded, or it can be transferred to the conveyors. So this is a simple direct actuation control of the single acting cylinders. So if you press the button here, obviously the piston will extend. So similarly, you will find a lot of applications. Another applications you may come across is the opening and closing of the doors. So with the help of pneumatic systems. So these type of systems you may find in buses or in malls, wherever you would like to control the opening and closing of the doors using pneumatic system, you can make use of these. So here you can see, obviously, in this case, we make use of pilot operated direction control valves. So the reason why it is called pilot operated is I'm not directly actuating onto this valve. So here the input is obviously given with the help of the another valve, push button valve. So the push button valve will send the air. The air is actuating these control valves. So the air is either pushing from this side or from the other end. So it is a double pilot actuated 5x2 control valve. So this in turn is directly controlling the forward stroke and the return stroke of the double acting cylinders. When it moves forward or when it moves backwards, obviously accordingly based on the mechanism that you have set, the door will open or it will close, right? So these are the various different applications. These are only limited applications. Of course, pneumatic systems have a wide variety or wide range of applications in industries, and I hope in this lectures you have understood the basic working principle of pneumatic systems. And this basically concludes the part 2 of the pneumatic systems. So these are some of the references which you can refer, these textbooks which you can refer for further reading. And that concludes this lecture. So thank you very much for watching.